All right, so to continue from last time, before we continue actually, I'm going to draw your attention to our Gantt chart again. Last week you should have read and understand the handout, set up and outlined your programs, and there was a question right beforehand what that means. It could mean, I mean, it's going to depend on how you go about programming, but what it means for me would be to set up the environment, create all of the source files, right? The mains and stuff like that. Start documenting things. Outline it as far as pseudocode goes. Well, first of all, I'm going to have to open up this file. Second of all, I'm going to have to process it line by line. Each line, this is what I'm going to have to do. If you outline your program in comment form, then that's what an outlining program means to me. And then when you realize, oh wait, I don't know how to do that. I don't know how to do I'm going to need to manipulate this string. I don't know how to do that yet, but I'm looking on the schedule and we're going to cover that. We're going to cover that today. You know, if you're deficient in that knowledge, then that tells you, okay, I need to go back. We did cover that, or I'm going to go to the pre-prepared videos and see, look and read about strings or watch about strings or something like that. So at this point, you should have, you know, a pretty good handle on getting started with assignment 1. What you should be doing as of starting on Monday is you should be designing your test cases so that you understand what the problems are. Honestly, I forget what they are. I think one of them is entropy is one of them. So you would come up with a string or a file full of words or letters or whatever, and then you would pull out your calculator and start calculating what the entropy of that is. Keep it simple. Or you could go out and you could find an external source that already has a solution for you, right? An online entropy calculator. I think one of the LAs was talking about that they found one online, and they use that to generate their test cases. That's perfectly fine. When you get to the full project, that's what we encourage you to do. In fact, we point you to a couple of websites where you can generate mock or test data and then use it. And so that's what you should be doing. That's what a good test case is. A good test case is not something where I'll create the input, I'll write the program, I'll run the program, that produces output, there's my test case, right? That's the exact opposite of what you should be doing. You should be designing your test case first independent of the program so that you know that it's correct, so that when you run it on the program and you get the correct, or your results match, then you know that that test case passes. If you are automatically just starting out with a test, or if you're starting out with the correct answer produced by your own program, you have no idea if your program is correct or not. That's what it spit out, right? So over the next few days, that's what you should be doing, as well as, of course, Lab 2 tomorrow. Remember that we are online, so if you have any questions, go ahead and post the live stream, or go ahead and post a Piazza. We'll come back to this here. Last time we left off talking about lists. In fact, we talked very briefly about arrays. I showed you how to use them using the new keyword to create a new array, an integer array, a double array, or whatever. But then we ended on, don't use it, because there are much better solutions out there. One of those solutions is a list. A list is an ordered collection, ordered meaning that there's a first element, there's a second element, there's a third element, ... there's a last element. For familiarity, it is indexed by 0. So the first element is at index 0, the second element is at index 1, etc. Just like an array, but it grows or it shrinks automatically as you put stuff in. You don't create it like an array where it's of size 10 and it will only ever be of size 10 for the rest of its life. You put something in and it automatically grows. Now it's of size 1. Initially it's of size 0. And if you add 5 more things, now it's of size 6. If you take out those three things, now it's of size 3. It automatically grows and shrinks as you put stuff in and take stuff out. You can use the add method. You can remove via an index here. Remove 1. Does that remove the first element? No, it removes the second element because indexing starts at 0, just like an array. And then we added a bunch of other names here. Removed by the name, and that takes out that duplicate Daryl value there. Right? So let's pick it up from there. You can have, we started out with a list of integers, right? And if I do that here, you'll see that it no longer compiles. Again, this is a parameterization. This Langle-Wrangle is a parameterization that says, this is a list for integers. If you try and go and add a string to it, you can't do that because this is a list of integers. So let me go ahead and change it back to what I had. But if you want a list of say, doubles, what would it look like? List of, let me try this first, double, right? Values equals new array list. And by the way, the second langle-wrangle here, you don't have to repeat what you did before. It's okay to do that, and that's older Java. You had to do that, but as of Java 8 or something like that, you can use elision. There's a 50-cent word. Elision is taking out the unnecessary parts, right? You're eliding it, you're shortening it up. And you don't have to put that second parameterization in there. You do have to keep that langle-wrangle there, but you don't have to, if you don't, then a warning will pop up. We'll talk about that later on. But you should have that langle-wrangle there. You don't need to put that, you can elide that string away. Why can't I use a small d double here? That's Java. Java expects that the parameterization is a class. Small d double is a primitive type. It's not a class. That's okay, because every primitive type, int, small I int, small d double, float, all the other primitive types that you have, they all have what are called wrapper classes. We used this before when we converted a string to an integer. Do you remember how we did that? Integer.parseInt, right? 10, something like this, right? This is a class. Big I integer is the wrapper class for ints. Big D double, how would I do that? Double y is equal to, what did we do before? Not integer, if you want to convert it to a double, it's big D double dot parse double, right? And 3.5, something like that. Right? These are wrapper classes that basically represent, that give you some additional methods, that give you some additional functionality, that give you a class representation of each one of its primitive types. So for integers, for int I, big I integer, small d double, big D double, right? And when you parameterize something, you can't use the primitive types, right? You have to use the wrapper class types. And so I'm going to use it here. Now, if I try to add something to values.add 3.5, right? That's perfectly fine. Values.add. Even if I add a number that's not a floating point number, that's still going to be okay. Why? No, okay, it's not going to be okay in this case. What should I put? 10.0, right? Or another trick here is I think you can do this. Yeah, you can add a D at the end, force it to become a double, or you can go ahead and use typecasting here explicitly, right? But I'm not able to do something like values.add foo, right? Again, values is a list for what type? Double. The compiler sees that, well, foo, the string foo, is not a double, so I'm not going to let you do that, okay? I'll go ahead and get rid of this, and there is a question online. Can you add an element to somewhere other than the end of a list? In other words, an insertion. Yes, you can. Let me go ahead and run this program, and you'll see that I've got Chris, Joe, Jane, John, Daryl, and Daryl. Let's go ahead and add Bob. Now, if I just go names.add Bob, and I print it out again, then it's added to the end. Right? So let's add it somewhere else. Dot add, and you can see I'm not going to complete this. I'm going to just go dot, and then all of these options pop up. It does have completion, so if you do it partially, it will narrow down those options. But you see here that I've got an add, which I can just add a string to the end. The documentation comes up right up here, but it's kind of small for you to read. But then I've also got an add with an index and an element. What is that telling you? Well, RTM, read the documentation. What is it going to do? Is if I say that I want to add it at index 2, it's going to go over to index 2, and it's going to make room for it automatically, shifting things down, and then adding your element right there. So let's go ahead and add Bob at index 2. Now what's it going to look like? It's not going to look like this before where Bob was added to the end. Where's it going to end up as? 0, 1, 2. So Jane is going to get shifted down along with John, Daryl, and Daryl, and I'll have Chris, Joe, and Bob. There we go. and everybody's been automatically shifted down. Seeing this kind of functionality, are you ever going to use a plain old array again? No, right? Why would you ever want to? Right? Okay, so that's great for lists, which again are ordered collections of elements. Right? Typically you use an array list implementation, so just remember this for now until we get to object-oriented programming and inheritance and interfaces. But what if you didn't want duplicates? Remember that Daryl right there? That he's a duplicate. Right? We've got 2 Daryls in there. So if you don't want duplicates and you don't care about order, what you can do is you can use what's called a set. A set in mathematics, what is a set? Right? Some of you are taking 235 right now. You've probably not gotten to sets just yet. Right? What is a set, though? Yeah. An unordered collection of, and I'm going to insert another word there, unique objects. So you can have what are called multi-sets, where you have multiplicity. In other words, if I add 10 to the set 3 times, I've got 3 copies of 10. That's a multi-set. But a regular old set is an unordered collection of unique elements. If I add 10 3 times, it's not going to affect it. There's only going to be 1 copy of 10 in there. And it's no longer an array list. The usual implementation is going to be what's called a hash set. For both of these, I'm going to have to hover over and import those. Once I do that, I get, come on, there we go. I get it to compile. Right? And I didn't have to change anything here at all. Why? All the collections, lists, sets, and the next thing I'm going to show you, maps, they all have, well, not the maps, but they all have a universal interface. They all have this add method. They all have this remove method, right? They all have a way of iterating over them and printing them out and stuff like that. There is one significant difference, though, down here. If you want to add Bob as at the index 2, in other words, the 3rd element, can you do that? No. Why? What did I say that sets were? They are unordered collections. So there's no such thing as the 3rd element. There's no such thing as the 1st element, the last element, etc. There are just elements. So I'm going to go ahead and modify this so that we're not adding it at a particular index. Does it indeed add it to the end? Well, there is no end. There is no beginning. There is no end. It's just a bag of things. You can see here, oh, wow. Bob ended up being exactly where I put it before. That's just a coincidence. Don't worry about that. But you see here that there's no order. Chris is not me. I'm not the first one anymore. Joe apparently is. Daryl, the second to last thing that we entered in, that ends up being the 2nd thing. Then me, then John, then Jane. So there is some ordering to it, but you can't rely on that. The other thing I'll bring to your attention here is we added Daryl twice. Do you see 2 Daryls here? Nope. Why? Because sets are unordered collections of, and there's my inserted word, unique elements. Adding Daryl twice has no effect. It's not an error. It's not going to throw an exception or die or anything like that. It's just, it's unique. So adding it has, we call it a no-op or a noop or a no operation, right? Noop, N-O-O-P, right? Nope. It's not nope, but noop, no operation. It just doesn't do anything, okay? So that's sets. But now here's an interesting question. Before, if I had a for loop, I could have iterated over it with as if it were a list, right? Here, let me go ahead and change it back to an array list, right? And I'll go ahead and iterate over it for int I equals 0. I is less than names dot size, I plus plus, system dot out dot println. I'll print the ith name. How do I get the ith name? Do I use that? That's a regular old poor man's array. I use get the element at the ith index. All right? And let's go ahead and print this, and we'll see that it's in that order: Chris, Joe, Jane, John, Daryl, and Bob. All right. Can I do that if it was a set, or if it were a set? Hash set. There we go. No, it no longer works. Why? There is no ith element. There's no first element, there's no second element, there's no last element. Therefore, there's no ith element. Okay. So am I dead in the water here? Now, what else could I use? You remember when we had arrays? We used this nice, cool, enhanced for loop that did not require an index variable. Well, here, we can't use an index variable at all. That's not even an option anymore because it's a set. So if I have a set, how do I iterate over the elements in a set? An enhanced for loop. For each string that is a name in the collection names, I can print out that name. Right? This here is going to change for each one. It's going to iterate, and it will then impose some ordering because it's a bag of stuff. It starts taking things out of the bag. The first one that it takes out of the bag, it prints. Then it takes another one out of the bag, it prints. Takes another one out of the bag until it gets all the way to the end. So in this case, it's printing Joe, Daryl, Bob, Chris, John, and Jane. Joe, Daryl, Bob, John, Chris, and Jane. Well, so Chris, John, and Jane. Okay, so it's matching the exact same order that I get if I printed that out. Right. Okay. How do I remove the ith element from this one? Names.remove. I want to remove the first element. Is that going to work? Nope, because there is no first element. So what are you wanting to remove? Oh, I want to remove me, right? And then I can print it out again and see that it is indeed removed. It'll automatically find it for you and remove it from the list. You can check, is it still in there? If names.contains Chris, then system.out.println, I'm still in there. All right. Is it going to print I'm still in there? No, because I removed myself. If I don't remove myself, then of course I will be still in there. Right? Although, am I in there now? No. Chris, all uppercase, Chris with the uppercase C and all lowercase, are those the same strings? Nope. We'll see that here momentarily when we focus more on strings. Otherwise, I'll just make sure that you have this in the notes. And I'll show you an even better collection. So Java, there we go. Before we do that though, let's note what our sets are. A set, capital S, is an unordered collection of unique elements. Right? In other words, no duplicates, no order, no first element, no second, etc. There is no duplicates. All right, adding stuff multiple times has no effect. What else did we observe about it? Right? Use an enhanced for loop to iterate over a set. There we go. All right. And of course, you can just go ahead and use dot, and you'll see that you have literally, or names, dot. You have dozens and dozens of methods that you can choose from here that automatically give you a lot of the core functionality that you're probably going to look for. For example, clearing out a set, creating a new set, creating a copy of a set, et cetera, et cetera. Right? What I'm going to show you now is even more powerful. Right? So think about an array, and even think about a list. Right? It orders things. It's a collection of ordered elements. But how does it order? You can think of it as an index mapping to a value. So for example, what I had before, let me go ahead and restore this. What I had before when I had a list of strings, and let me go ahead and get rid of that, was an ordering. Chris is associated with index 0. Joe is associated with index 1. Jane is associated with index 2, et cetera, et cetera. You can view it kind of like an integer to a string mapping. Well, what happens when we take that idea of a bunch of keys, a bunch of mapped values, and then a bunch of values that get mapped to, and we take it and we take away the requirement that it has to be a bunch of integers and it has to start at 0. What we get instead is a map. Right? So what I'm going to do is let's map names to ages. Right? ... So I'm going to map a string, which is a name, to an integer. So now here's some additional syntax. Within that Langle Wrangle, I've got two parameters. I want to map a string to an integer. Right? And I will go ahead and use a hash map here. Right? Kind of like a hash set, but it's a map. It's mapping a key to a value. Right? So strings, these are keys, representing names, will map to values representing an age. Right? So let me go ahead and bring these in, import this. All these things, by the way, are in java.util. They're not in the standard Java language library. They're in the utility library, java.util, ArrayList, hashmap, et cetera, et cetera. Okay? Now, I can no longer just add things to it because before with an array list, it was automatically assigning and designating the indices for me. Now what I'm doing is I need to map the name to an actual integer. I've kind of like reversed it. Instead of an index, I'm using the name itself as an index, as a key. So I'll map Chris here. I assure you I'm only 32. Right? There we go. Joe is 45. Jane is 39. 22. The first Daryl is, say, 24, and maybe they're twins. I'll go 23 here. And Bob, I'll map to, he's 90, right? I think Bob Newharty's still alive, but I'm not sure, right? If he is, he'd be up there, right? I can't add things anymore. It's a different interface. It's a different way of putting stuff in. There's the emphasized word there. I'm going to put stuff in. And you put Chris mapping to 32. You put Joe mapping to 45. I don't want to type a lot, so trick. Put, done. Oh, wow, cool. How did you do that? How did I do that? No? All right, that was called block selection mode. On Mac, it's going to be Option Command A. I believe on Windows it's going to be Alt Control A. Don't quote me on that though. But it puts you into a block selection mode. Instead of selecting line after line after line, you can select columns. You can select a square. If you select a column like this and start typing, right, it's going to repeat the entire same thing for that selection. Undo that, undo, 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 right? Undo, there. Go out of block selection mode by the same quick keys. Right? And it's somewhere up here, I'm sure. Where is it? Edit, block, you'd have to look for it. Block selection mode, I don't see it. Anyway, you'll find the quick keys. It's just a trick. Right? Anybody know what it is on Windows? No? All right. It's very, very useful. I hate text editors, code editors that don't have some sort of block selection mode because it is extremely useful. Right? Okay. So when I print this out now, what is it going to look like? It's going to now look like a map. Right? And anybody coming from say a Python background is going to immediately recognize those curly brackets as a dictionary. A dictionary is kind of like a map. It's just a way less powerful map because in Python you can map strings and integers to whatever you want, but not much else. This, in Java, you can map any type of class to any other type of class. I could map strings to strings. I could map integers to integers. I could map doubles to integers. I could map strings to integers or integers to strings, back and forth and back and forth. It's extremely powerful. What's an immediate use you could think of in, say, your assignment? Because remember, you have, I don't have the Gantt chart up anymore, but remember that you have read the handout, right? What's an immediate use of a map that you could think of? Say in the entropy exercise. What could you map from and what could you map to? You could map a character to the number of times you've seen that character, right? It's frequency. So that you didn't have to do your own bookkeeping with a regular old array or something like that. It's extremely powerful, right? Use it. Okay? All right. I'll make sure, oops, sorry. I'll make sure that you have this in your notes. All right, yeah, oh, good question. So you want to change what something is mapped to. All right, names dot put. Bob is actually not 90. He's a very youthful 20. Oops, there we go. And that replaces it. And you see that Bob is now 20. Right? If you wanted to remove something entirely, names dot remove. You're removing it by the key, so you would end up removing Bob. There we go, and now he's gone. Yeah, go ahead.
It does so in an unsorted way, right?
It is unsorted. It is unordered, you should say. Yeah, sorting, ordering are a little bit different. Ordering means that you have the concept of a first thing, second thing, third thing, but sorting means that the first thing is the first thing when you actually sort them, right? Alice, Bob, Joe. That's sorted, but you could still have Bob, Alice, Joe, and it's still ordered because Bob comes first. It's just not in a sorted manner. Another question.
How would you implement the integer
The integer
mapping?
what?
Like in order to implement what's age, how would you do that?
Okay, so to get a value out with the key. So int Bob's age is equal to names.get, and then you give it the key, and all system.out.println Bob's age. There we go. And I'll get 20 out of, Bob's age. Oh, because I removed it. There we go. So what is this? Cannot int value because it returns a null value. So let me go ahead and go with integer here, capital I integer, and show you that because I removed Bob as a key, I can no longer get his age, and so it returns null, and that's what ends up getting printed. Let me go ahead and get, instead of Bob, let's get Joe. Oops, Joe. And Joe's age. Joe's age. Joe's age. And run it again, and now I get 45 out of that. Right? So you can put stuff in, you can take stuff out, you can retrieve stuff by the key, and then of course you can make changes once you've retrieved it. Yeah? They're not duplicate keys because that would not be a map. If I had like 5 maps to, or Joe maps to 45 and 50, how old is he, right? Which one is it, right? You can't have that. In fact, a map is a function, right? And if you're in 235 right now, you'll eventually cover what a function is. You know that, but you know from even from K through 12 what a function is. Is a circle a function? Why? It's not. Why? Because it fails the vertical line test. Why? Because a single x maps to 2 values. You can't have that. That's not a function. That's not a map. You can have what's called a multi-map. You'd bring in a library to do it, though. Like there's an Apache Commons library that has multi-sets, it has multi-maps, it has bijections, so you can map back and forth. You can retrieve a key via the value. Here you can't do that. You can only go one way. That's because it's a function. Right? What else? How do you iterate over it? Well, I can't go int I equals 0, I is less than n, I is less than whatever, because the index values here are not even integers anymore. They're just strings. So how do I iterate over the values? I iterate over all the keys. Right? There are several ways of doing this. I'm going to show you the easiest way. What are the keys? The names. Right? In names.keyset. What that does is that returns all the keys in this one bag. It takes all the keys, throws them in this bag, and gives it to you. It's a set. So how did we iterate over a set? With an enhanced for loop. Once you've got the name as a key, you can always retrieve the value. So integer value is equal to names.get name, and then you can system.out.println name is value years old. There's my nice way of printing everything. Joe is 45 years old. John is 32, or Chris is 32 years old. Jane is 49 years old, et cetera, et cetera. Right? Oh, thank you. Somebody says online that Bob Newhart is in fact 92 years old. There we go. Fact checking me in real time. Good job. I'm amazed that I was that close though. All right, so there are maps in Java. Questions so far? No? Again, once you learn about lists and sets, you'll never go back to arrays. Once you use maps, then a whole world of easy problem solving opens, right? Smart data structures and dumb code are a lot better than the other way around. Using a map relieves you of the need of doing a lot of bookkeeping, right? All right, let's go back over here. Sets, maps, strings. Talked about strings here. So now let's get into a little bit more. Java has a string class, but there is no memory management. If you want to create a string, go ahead. It'll allocate the memory for you. It doesn't matter that I want to concatenate these two strings together. I need to go and allocate enough memory to hold both of them plus the null terminating character. You don't need to do that. No null terminating character. Right? Now, internally, it probably does use a null terminating character or something like that to understand where the end of a string is in memory. We don't have to worry about that at all. It's all completely opaque to us. We just have to use strings. And you can do that by creating a string S. If you want to concatenate a string, what do you use again? Plus. Oops. Concatenation. Use the plus sign. Exactly. Right? Another thing to realize, though, that is in contrast to C and some other programming languages, are that strings are immutable. Once created, they cannot be changed. So, for example, let me go over here and show you a demonstration. Let's go ahead and create a string. S is equal to hello, or I think I did this last time, didn't I? Right? Let's go ahead and go with string T is equal to S, and then S is equal to capital H-E-L-L-O, right? Did that change the original string? Nope. Let's print these both out. Dot print ln s and t. There we go. So hopefully you remember from Computer Science 1 the difference between a deep copy and a shallow copy, right? What is a think about these in terms of pointers, right? If I create a string called with hello all lowercase, then I'm creating a string. If I say that t is equal to s, then I'm making a reference to that same thing. They're both pointing to lowercase h-e-l-l-o. Right? That's called a shallow copy because they're referring to the same thing. In C, where strings are mutable and you can change them, if I change that first character to an h, it's changed for both s and t that are referring to the same thing. In contrast, a deep copy means that you've got two different strings. So if I've got h-e-l-l-o all lowercase down here, and or up here, and h-e-l-l-o with an uppercase letter over here, they are two distinct things in memory. Changing one does not affect the other, right? And vice versa. So what do I have here? I have a shallow copy. T ends up referring to the lowercase h. Here, I'm creating an entirely new string. I am not changing the original string. The original string, lowercase h, is preserved in T. So when I print this out, what's it going to print? The first hello is going to be uppercase or lowercase? Uppercase, because that's the way that I said it here. But T is unchanged with the original string. It's going to print lowercase. It's preserved. Any attempt to change that string, for example, if I did, say as in Java, I said T sub 0 is equal to capital H, right? That's not even going to compile in Java, right? I could do something like this in C because strings are low level. It's just a character array. Strings here are a class. Underneath the hood, there is a character array sitting somewhere, but that's all opaque to us. You can't do something like this. You cannot change strings once you've created them. You can only create new strings. If I create another string here, string LSTU, S plus T, that is concatenating those two things together and creating a brand new string. It doesn't change the other strings at all. Right? So how do you go about changing strings? For example, what if I had string name or message is equal to hello. I'll do it like this, hello world. MSG dot. Now here's the standard string library. Every language is going to have some sort of string library that you can use so that you don't have to reinvent the wheel. There are dozens and dozens of methods that you can call to get certain things. For example, what if I wanted to convert it to all uppercase? To uppercase. Okay. Does that convert the actual string? System.out.println, println, MSG. What's this going to print? Is it going to print all uppercase HELLO world? Let's find out. No, it doesn't, because they're immutable. Once I create that string MSG, I cannot change the contents. And you can see here that the contents are not changed. What this is doing is it's returning a new string that is a copy, a deep copy of the old string with all the characters converted to uppercase. If I fail to capture that returned value, that's on me. String converted. Once I capture that value, you can see that it is indeed a different string entirely. Now what's this going to print? Hello world, and then all uppercase hello world. Right? Every single one of these functions or methods is going to return a new string or return something else. It's not going to touch the old string because it can't, because strings are immutable. You cannot change them. The opposite of that would be mutable, where you can change things. Okay? Well, what if I want other things? For example, I just want the first letter or something like that. Get a particular character from a string. Right? If this were C, I could go MSG sub 0 to get the first character. I can't do that here. Why? Because it's not an array. If you wanted the first character, you can still do it. It's just that you have to work through the methods. MSG.character at 0. That gives me the first character in that string. Right? And I can print it out and show you that it is indeed an uppercase H. Right? There it goes. What if I wanted to get the character at index 6? Right? And it is indexed at starting at 0. So that'll be the 7th character. What is the 7th character in Hello World? 0, 1, 2, or 0, 1, 2, 3, 4, 5, 6. It'll be capital W. Right? What if I wanted the 60th character in that? That's way out of bounds, right? So what would you expect? Some red text telling me so. You can't do that. Right? String index is out of bounds. Right? It's out of range. So let me go ahead and restore it to only 0. What if I wanted, say, a substring? Right? Substring. Substring string. There we go. Well, MSG dot substring, subsequence or substring. I've got several different versions here to choose from. You want a substring beginning at a certain index, at index 6. What will that return? System.out.println. It'll return, well, what starts at 6? The capital W. And so the rest of it will be, oops, print. There we go. World. All the way to the end. I don't want to go all the way to the end. I only want it starting at W and going all the way to D. So W, and then that's going to be 6, 7, 8, 9, 10. If I go 10, that will give me the substring, 11, I guess. There we go. I need to go one more because it is minus. How do I know that? Hover over it, read the documentation, read the examples it gives you. Basically, it'll be this minus this is the length of the resulting string. So 11 minus 6, that's going to be 5, W-O-R-L-D. Right? That's how I got that string. So if you want to go to index, you need it's the last index minus 1 right? And that's because of how indices work. It starts at 0. It's just a little trick. Questions so far? No? Well, again, if you have anything that you want to do, look it up first. Does it contain a substring? Right? Can you do certain things? For example, if I had CSV data, string, CSV data equals Chris, Bert, Shore, 105. There we go. CSV data, comma separated value data, right? How can I, what is that called in C when we want to chop that up? It's called tokenization, strtoke. In this case, though, CSV data dot split is what you want. Split takes an entire regular expression. We won't get into that just now. But for your purposes, you can go ahead and split on any comma. What does that do? It returns an array of strings. Right? Why? Because this function existed before there were collections in Java, or before there were parameterized collections in Java, I should say. So string tokens, we call them tokens. Right? Chris is the first token, Burke is the second token, Shore is the third token, and then there's a fifth token there. If you want to print this out, you can see what it looks like. So system.out.println tokens. And you'll see that it's been split up along that delimiter. Oops. Tokens is an array. So if you want to print out an array, arrays.toString tokens. There we go. And that'll print it in a nicely formatted manner. Right? These commas are not part of the strings. They take out those delimiters and throw them away and just give you the tokens. Yeah?
Is there a way to put that into the list instead?
Yep. So list of, it'll be, in this case, strings, tokens. I'll shorten this to just tokes. Tokes. All right. Tokens is equal to new, come on, array list. There we go. And then for string s in tokes, tokens dot add s. That's the long way of doing it, right? That's the manual way of doing it. Another way of doing it would be, I think you can do it something like this: tokes arrays dot toList or as list. Nope, that won't work. ToList. Nope. List dot nope. List dot of. No, I don't think this may not work. Of tokes. I'm trying to think of the one-liner, and there we go. That's the one-liner. That's the easy one-liner. Let's print out tokens now. There we go, and yay. All right, that's the one-liner. Of, so list.of, you give it an array, and it automatically converts it. Also, it preserves the order if it's a list. If it's a set of strings, unordered tokens, is equal to set.of. Same exact thing here. Talks. And the order is not necessarily preserved, but in this case it just happened to be, right? That was just a flip of a coin there.
You want to print out.
Oh, thank you. U tokens. Maybe I was wrong. There we go. Okay, now it demonstrates that it's unordered. Thank you for demonstrating that it is unordered, right? All right. Questions on strings so far? Otherwise, I'll make sure that you've got this in the notes, and then I'll talk about, well, what if I really want a mutable string? You can. It's going to be a little bit different. It's going to be what's called a string builder. SB is equal to new string builder. A builder is something where you can construct something, and until it's completed, you can change it, right? You're building a building. Oh, okay, well, I want to go ahead and add a third floor, right? As it's being built, you can change it. Okay, I want the walls to be white instead of blue or whatever, right? As you're building it, you can change it as much as you want. SB.append hello, sb.append, a space, world, right? sb.append, and then that end line character, right? Except that I misspelled hello, H. Now this is mutable because you can change things. What is it? Set character at index 0 to be a capital H instead. Right? If I printed it before I did this, you would see that system.out.println sb. You would see that it was a lowercase h. After I've corrected my mistake, you'll see that it's an uppercase H, right? And now I can build it. If in the end you actually want a string, or if you need a string, you can go ahead and dump your string builder to a string, sb.toString. String final str is equal to this, right? And now, any attempts, of course, now you've got just a regular old string that you can't change. It's immutable, right? By the way, immutability is a very, very good thing. Immutability guarantees that it's going to be thread safe. Threads are multiple, we live in a multi-threaded world now where you've got different actors that are independent. You've got one program, but you've got these threads that can run on independent processors all at the same time in parallel. Now, you want things to be thread safe in that you can't have you don't want one thread coming in and changing the data after another thread has looked at it. If one thread looks at this and says, oh, this value is true, and it uses that to make a decision in its process, and then another thread comes in and changes it to be false, this thread is now operating under a false assumption, right? So what you want is you want thread safety, that if a thread comes in and sees the condition that it needs to decide something to do, that condition should not change for this thread. You shouldn't allow this thread to come in and step on its toes. Thread safety means that you're putting a lock around that so that it sees what it needs to do, it sees a condition, does what it needs to do, and within that time frame, everything is synchronized and this thread is blocked from making any changes. Right? You get all of that for free with immutable data. If you've got immutable data, you have a guarantee that one thread cannot change the data because the data cannot be changed, period. Right? Thread safety, immutability is a very, very good thing to have. And that's why everything built into Java, with a few exceptions like string builder, are immutable by default. Big D doubles, big I integers, strings, you cannot change them once they've been created. You can syntactically create a new one with a different value, that's perfectly fine. Small I int, small D doubles, those are mutable, because if they weren't, you wouldn't call them variables. You'd call them constants. Right? All right, so there's string builder. Sometimes you'll need it, maybe, but mostly work with strings. All right, questions so far? All right, then we have enough. Let's do an exercise. So this is an old homework from a few years ago. One of the things is repeated here, but we won't look at that. We're going to look at this isotope half-life. So so again, let's go through this process in our Gantt chart, reading and understanding the handout. We'll do an accelerated version of it. Setting up and outlining our program, maybe designing our test cases, and then coming up with a first rough draft of how to go about doing it. This half-life, basically, you're given a radioactive isotope. In this case, the example is strontium-90. Right? Strontium-90 is a radioactive element. It releases radiation, but it also decays over time. The half-life of its original mass is the number of years required for, say, 10 kilograms or grams or whatever your measure is of this radioactive isotope to decay into some other isotope or into a stable byproduct. Right? This one, I think, after about 28.9 years, you'd have 5 kilograms of uridium-90 and zirconium-90. Those are the decay products. But you would still have 5 kilograms of strontium, right? So this is how, this is basic physics. This is how, radioactive decay works, okay? I give you a formula here that if you start with an initial mass and then you raise, let's see, what is C? C is just a constant here. And you raise that to the number of years divided by the half-life, That's the amount of mass that you would have after that many years, right? So for example, if I just said, well, I've got 10 kilograms of strontium-90, after 1 year, and its half-life is 28.9, raised to the C, and that's just a constant, how much do I have left, right? So to understand this, to read and understand this handout, let me just go ahead and bring up a website, Wolfram Alpha. So let's see how this works. What was C again? C is this thing. There we go. And if I start out with 10 kilograms of strontium-90, E raised to this value, and then that value raised to, after 1 year with a half-life of 28.9 years, how many kilograms of strontium-90 would I have left? Right? Since it decays over 30 years, I'm still going to have 9.73 kilograms after 1 year. Right? What about after 2 years? What do I have? 9.5. So it is this exponential decay. What if I go for, say, 30 years? How much should I have now? Less than 5 kilograms. 4 point something, something, something. There we go, 4.87 kilograms, right? Now, by simply using an external tool here, what have I done? I've already created my own test case here. 9.73, 9.54, or 53, whatever it was, right? And then after 29 years, instead of, I put in 30 instead, I would have 4.99, right? This is how you create a test case. Another way that you could do a test case is, well, let's look up an online calculator. Half-life decay calculator. Right? Half-life calculator. Right? Oh, okay. I could plug in a bunch of values for that. Maybe do it over 5 years or something like that. And I would have created my own test case. And there are dozens and dozens of calculators like that out there. It is not cheating to use an external tool to generate your test cases, all right? To verify your test cases. A calculator is an external tool, by the way, right? So it is perfectly fine to use those things, or just Wolfram Alpha here, right? So there's my first test case, and we'll go ahead and steal this one, right? Instead of writing our own, because I want to focus on the coding instead. So let's come over here. Let's read the instructions actually first. So you're going to take as command line arguments all these things. We're going to name our class Isotope. We're going to take the atomic number. We're going to take the name of the radioactive isotope. We're going to take the atomic symbol, SR in this case. We're going to take the half-life in years. And we're going to take an initial mass, 10 kilograms here. Right? So we're going to take all 1, 2, 3, 4, 5 command line arguments. And we're going to produce a table that looks something like this. Okay? Questions so far on that? No? All right. And by the way, what we need to do is we need to produce a table that looks like this. The second that it gets down to below half of what it originally was, that's when we're going to stop this calculation. Okay. So let's go ahead and create a new class, Isotope. Right? Note that I put it in the unl.csv package. Right? Whatever package it says to do, what did it say to do here? Main section, format, I don't know if it said find package. Right, the default package. What is the default package? The default package is no package, and that's going to be up at the root. But I think that most of your, I think this year's handout says put it in the UNL CSE package. Right? If you put it in a different package, it is a different class. You can have the same class name, in different packages. They're going to be different classes then. Right? That's why you can have a list that is part of the standard the utility library, and then you can have a graphical user interface library with its own list. Right? You don't have these naming conflicts like you do in, say, C, where you're polluting the namespace. Right? Yeah.
Is that for like web creator purposes?
That's for web. Yeah. Most. I mean, we have to know what package it's in. Now, when you get to your project, we're a little bit looser on that because we've got way more sophisticated scripts in the background, and I think that you only need to name it one. One class needs to be in a specific location, and that's it. Where you put the rest of your classes, That's a design decision that's left up to you, but that you will be graded on, right? If you put everything into one package, not a best practice, right? Make sure that you're organizing your code and putting things where it makes sense to put them, right? Math stuff belongs in the java.math library. Utility stuff like lists, sets, that's in java.util. Other things like string, that's in java.lang. It separates everything out into these other packages. Okay. I will need a main, so public static void main, string args. Right? And I'm going to need to check, first of all, how many command line arguments there are. I'm expecting, again, how many? 5. So if args.length is not equal to 5, right? Remember in C, the first one is argv sub 0. That's going to be the name of the executable file. We don't have that in Java. I'm only going to expect 5. This isotope here, where we gave an example, this thing right here is not part of the command line arguments. That's the name of the class. You don't need, so it's not provided as command line arguments. I'm expecting exactly 5 here, right? Not 6. I'll go ahead and put out an error message here. Now, normally, what I've shown you so far is just println and system.out.println. Error, provide, what were they again? Let me go ahead and copy these and then put them over here. Provide the atomic number, name, atomic symbol. Everybody remember this from high school physics, right? This is high school physics topics? Yes? No? Maybe not. I don't know. This is the last time I saw this stuff was in high school. Half-life and mass. There we go. There. That's an error message. You need to provide those 5 command line arguments. Now, at this point, if they did not provide those command line arguments, can I go forward? They only gave me 4. They didn't give me the initial mass. Can I possibly compute that table? I could put in some default, but that would be kind of weird, right? Always default to 1 gram or something? I don't know. Right? So, what should I do on them? Quit. System.exit. Does that look familiar? If you're coming from a C background, how did we exit out of a program prematurely if we wanted to? Exit with an error code of 1. System.exit. Not only that, but I'm not going to use the standard output here. I'm going to use there's a standard input, there's a standard output, and then there's this third thing called the standard error. Right? And that's how we ultimately get this red text right here. Anything that is piped out to the standard error in Eclipse is going to be highlighted with red, telling you, flashy, flashy, this is an error. Right? It came from the standard error. Right? The standard input, by the way, I can't type anything right now, but if you are going to use the standard input, it ends up being green. I don't think that you'll have need to use the standard input, but where do you think it is? System.in, right? And if you wanted to create a scanner for that, we'll talk about scanners later on. Right? But otherwise, that checks to see if there are command line arguments, enough command line arguments. Now, 2 of these things, or let's see, 3 of these things are numbers. 2 of them are strings. So let's go ahead and store those into sensible variables. There we go. I'll just use this as a reminder here. Right? So, by the way, if you were outlining instead of actually implementing this, what would you have done? Check command line arguments. This is an outline. Convert command line arguments. Right? Then, write your loop. Loop. While we still have greater than 50% of the original mass, ... and then you would outline what you need to do. Compute the new mass, right? And then continue, right? Compute the new mass, or output the line, compute the new mass, and move on, right? This is what I'm doing in my head when I'm outlining. If it helps, actually put it into comments. Now, do those comments stay there when you're done? No. You get rid of them. That's superfluous. Right? Only code should be self-documenting. You don't need to say check command line arguments here, because anybody who knows Java is going to see, oh, well, they're checking the command line arguments. It's self-evident. It is self-documenting. That kind of documentation is not needed. What kind of documentation is needed for this course? Doc-style comments with the author, the date at a minimum for your first homework here, and the purpose of the program. So author, I've got that implicitly there. Date would be 22/01/25, and purpose, right? Computes a radioactive decay table given a radioactive elements properties, right? That's all you need to do, right? But the great thing about doc-style comments here, and by the way, doc-style comments are different from multi-line comments. This is a multi-line comment. You'll note here that it's in green, right? This is a multi-line comment. What's the difference? There's another star up here. The difference is also that you can use these kind of @ annotations, and not only that, but you can use basic HTML. So if I want to say, look up the Wikipedia page on Half-Life, Wikipedia on Half-Life, hopefully not the game comes up, but Half-Life, there we go. So you want to read more all about the physics of half-lives, right? More info can be found here. href equals whatever here. Now, if you know HTML, great. Go ahead and start using it. If you don't know it, that's fine too. It's not required. But I'm showing this to you so that you can see what the advantage of doc-style comments are. Right? It's now formatted, and I can actually, you can see, you can click this. Right? There is a built-in web browser in Eclipse, and it takes me right there. Things are clickable. You can refer one documentation to another piece of documentation. You can refer documentation to an external resource that they can go and read about this really special algorithm that you've come up with, right? You can only get that with doc-style comments. Just get into the habit of using doc-style comments. In general, every class needs comments. It needs documentation. Non-trivial functions need documentation. Main is a trivial function. Everybody knows what the purpose of a main is. It's the main entry point of the program, right? Later on, when we look at more methods and functionality, we'll start to discern what is a trivial function and what's a non-trivial function, all right? Okay, well, here, let's make our first function. I want to know how much I have left given the number of years and the half-life and the initial mass. Let's go ahead and put that into, if I've got a formula like this, what's it screaming out to you to do? Put it into a function, or in this case, a method, right? So let me go ahead and write another method here. Public, double, I don't know, what should I call this? Given those things, given the mass, given the year, again, this is just a constant here, given the number of years, and given the half-life, I want to compute how many kilograms or mass remaining. Right? What should I call that? Mass remaining, okay, or mass remaining, or get mass, or remaining mass, right? So for those of you coming from Computer Science 1, what are the two most difficult? There are only two difficult things in computer science. What are they? Naming things, and the other one is cache invalidation. Cache invalidation comes first, and then naming things. All right, fine, get mass. Public, static, double. Don't worry about static for now, just use it. Right? All your functions for the first assignment will be static, if you choose to make any. So should I have mass, double, years, double, half-life? One of those things is right. Two of those things is wrong. Right? No, ignore the compiler issue here. Mass, is it always going to be an integer? Not necessarily, right? In fact, look at our table. Are those integers? Nope. So what should it be? Double, okay. Why not a float? A float is just a cheap double. Right? Right. There are situations in which you would want to use a float because it's more efficient. Game engines, for example, typically we'll use floats instead of doubles because you do not need 16 digits of precision when ultimately the rendered picture is accuracy is only down to 1 pixel, right? I think what is it? You need only like 50 digits of pi to get down to 1 quantum of the entire universe or something like that. So you don't need that many digits. You don't need that many significant figures. There are some applications where a float does make sense. In this case, though, I'm just going to go ahead and always go with a double. What about years? You could do that. How much do I have after 2.5 years? Okay. But I'm convinced if you want to go with int initially, right? That kind of difference is a design decision that's left up to you, right? Which one is more versatile, though? Certainly, a double. All right. And then half-life is, of course, years, because the very example that we started out with is 28.9 years. All right? So there's that formula that I cut and paste. How much remaining mass should there be? Mass times c raised to y divided by h. Double remaining is equal to this. Is that going to work? Nope. There's several problems here. First of all, carets. Can you do a caret? No, caret has a different meaning, actually. Caret, you can do carets, but what it is it's a bitwise exclusive OR operator, right? We're not going to do any bit twiddling, so ignore it. Forget about that it even exists, unless you want to do some bit twiddling, right? Instead, what do I need to do to raise x to some power? Math.pow. Right? Now, if this were c, of course, I would just have pow, right? Raise c to this value right here, right? But I don't. This is not C. This is Java, which is an object-oriented programming language, meaning that everything is a class or belongs to a class. Math functions like pow belong in the or they live in the math library, math.pow. C? Is that anything you ever heard of? Nope. Well, what was C? C is just this constant here. What was it? E to this negative, it's actually, I think, just 0.5. That's why we call it half-life, right? 1/2. But I put it here to obfuscate it and to get you to use some, not you, but this class 3 years ago, to get you to use some more math. Yeah? Oh, sorry. Now, yes, something like that. Yeah. I don't know. Let's find out. Wolfram Alpha. All right. Nope, that's minus. So Wolfram Alpha does allow you to use carets. And okay, so it's slightly off, but that's probably just because I don't have as many significant digits here. In any case, I wanted to use it as an opportunity to define a constant because it's not a variable, is it? It's a number that's not going to change. So let's go ahead and create a constant. Public static double. And I'll call it C because in the handout, I didn't give any other descriptive name besides this. It's just a base, right? Is equal to e raised to the negative 0.693, right? It is perfectly fine to use this mysterious C number unless you know what it is, right? It's, I don't know if physicists have like a name for it. Anybody? No? Okay. Like if it were Planck's constant, it would be called mu. If it's E, it'd be called E. If it's pi, it'd be called pi, right? It's perfectly fine to use magic, mysterious variable names like this if that's what's used by convention. Right? But I can't use E. What can I use? Math.exp. I could use math.e, right? Capital E, but can I use that caret? Nope. I'm going to go math.e raised to the power of negative 0.69, or I can just go ahead and use exp. That's implicitly base E. There. What are you complaining about? All right, that's cool. What was it complaining about? Tell me. I copy-pasted from that handout, which was a PDF file. That looks like a minus sign to me, doesn't it? Is it? Nope. It's a special Unicode hyphen character. It is not the thing that you get on your keyboard. Get rid of it. It looks exactly the same, but it ain't, right? So Java does have support for native support for Unicode characters. You can name a variable the poop emoji if you really wanted to, right? Don't do that, right? It's bad, very bad practice, but otherwise like a smiley emoji, right? You can cut and paste this kind of stuff and put it in your code either as a, all right, I don't think that's actually, there we go. That's the one I want. I can put that into a string. Let's go, I'll go down here. String MSD is equal to, I can put that right in my editor, right? And it's perfectly happy with that, right? It's complaining about the next line. I can even have a variable called that. Nope, okay, it's not gonna let me, hey? Nope, okay, it's not gonna let me, oh, that is a semicolon, that should be semicolon, but it's still gonna complain about that. You can configure it to do so though. I've seen it done. It is not a very good idea though, right? All right, so there was a question though? No? Okay, all right. All right, so I just need to finish this out. It's not y years, right? Y is a bad variable name when it stands for years. Years is a good variable name when it stands for years. And H is the bad variable name when it stands for half-life. Right? Name variables what they represent, right? Now it's still complaining here why. It expects what kind of return value? Double, right? And am I returning anything? Nope. Add a return statement. Return remaining. There. Yeah, go ahead.
So do you always want like the get mask method in front of the main, or do you want it after?
Good question. Unlike say C, it doesn't the order does not matter. You can put it down here. Generally though, mains are the last thing in a file. They're all the way at the bottom. Member variables, static stuff is at the top. Then non-static member variable stuff. Then non-static methods, etc. But otherwise, syntactically, as far as the compiler is concerned, it doesn't care. Right? Now, this is an example of a non-trivial method that requires documentation. Mass, years, half-life. Right? Mass especially needs documentation. Mass is in what units? Kilograms? Mass, initial mass in kilograms. Right? You would only know that by looking at the documentation. Otherwise, 5 what? 5 grams, 5 kilograms, 5 pounds, right? 5 whatever, right? One of the websites I looked at before I got here had like 20 or 30 different units that I'd never even heard of, like CPM or something like that for atomic mass stuff, right? I'm not a physicist at all. There are programming languages, by the way, I'll end on a note here, that there are programming languages where you can define units. It's called strong typing. You can define this integer, which always represents kilograms, this integer, which always represents grams. So if you take A, which is in grams, and B, which is in kilograms, and you add them together, it'll automatically do the conversions for you, right? If you have this really strong typing. It is not at all common in programming languages. So in the programming languages that people actually use, what do we need? Good, proper documentation. All right. Oh, yeah, somebody points out that this is high school chem stuff, not physics. All right, fine. Right. Any questions? All right, then we'll continue on Thursday.